Hey everyone, welcome back to the Physics Unit 2 videos. In this video, we're going to specifically look at speed and circular motion. So we can determine the speed of an object traveling in a circular motion using the following equation. So here we have v is equal to 2 times pi times r, all divided by capital T, where v stands for your speed, which should be in either meters per second or kilometers per hour. R is your radius, which can be in either meters or kilometers. And then T stands for your period, which can be in either seconds or hours. So I've got two things here to note before we move on to an example. The first note is that you guys need to be working with similar units. And what I mean by similar units is that, say if your speed is in meters per second, then you need to make sure your radius and your period are also in similar units in terms of meters and your seconds matching. Okay? So if you're working with kilometers per hour, you need to make sure your radius and period are in terms of kilometers and hours as well. So you want to be using similar units. So you can't just have meters per second, kilometers, and then hours. You have to be working with the same type of unit. The second thing that I want to note as well is that if you guys have the option of working with either meters per second or kilometers per hour, typically what I recommend is that you guys work with meters and seconds in terms of your units. This isn't so important right now, but later on in our course, we are going to be working with a lot of questions where you can only have units in terms of meters and seconds. So this will kind of give you a little bit of an advantage and get you prepared for what's coming on in the course. So if at all possible, you should be working with meters and seconds. It also wouldn't hurt to have some extra conversion practice. But for right now, though, I will accept either or answer unless if I've stated it in the question. So we're actually going to look at an example from our notes, which will be number 1 from our speed and circular motion section. So if the Earth has an orbital radius of approximately 1.50 times 10 to the 8 kilometers around the Sun, and it makes one complete revolution around the Sun in 365.25 days, how fast is the Earth traveling around the Sun in meters per second? So just like with all of my other videos and all my examples, if you guys haven't noticed, I always like to write things down first. This kind of helps me wrap my head around what kind of information I have, and when we get to start adding on more equations, it'll help us identify which equation to use. So in our first sentence here, we're actually given this orbital radius of the Earth, and that is 1.50 times 10 to the 8 kilometers. So in this question here, it specifically says to be working with meters per second. So what I want to make sure that I do is I convert this kilometers to meters. And then in order to do that, we're going to use unit analysis. So here we know that there is 1,000 meters in 1 kilometer. So essentially what we're going to do is we're going to take this radius and multiply by 1,000. If you can plug that into your calculator or do that in your head, you guys will find that you have 1.50 times 10 to the power of 11, and our new units here are in meters. So the next bit of information that we're given here is what we call our period. So your period is how many seconds it takes to make one complete revolution. So this here is 365.25 days. And so this one here is, we don't have to do any work. This one here just gave us just a straight up value for our period because it takes 365.25 days for one revolution. One thing that we do have to do here is the fact that our units are in days, but we need to be working with seconds. So we can once again use unit analysis. And depends on how well you guys know your conversions. If you guys aren't a little bit very familiar with this, then that's fine. Just break it down step by step. You can maybe start with the fact that you know that there are 24 hours in one day. And then you can also do this one conversion here as well, that you know that in one day, or sorry, and I guess here we should be working with hours. In 1 hour, there's 3,600 seconds. So here we're canceling out our units of days, canceling out units of hours, so we're only be left with seconds here. So essentially to get our period into seconds, we're going to take 365.25, times it by 24, times it by 3600. And when you plug that into your calculator, or if you are very good with doing some mental math, you guys will get 31,557,600 seconds. So here we have our radius, and here we have our period. So now what we can do is, now we can go ahead and use, start by writing down our formula that I'd given above. So that one there is V is equal to 2 pi r divided by your period. So plugging in our information, we have 2 times pi times your radius, which is 1.50, times 10 to the 11, all divided by that period of 31,557,600. So depending on how you guys like to work, you guys need to put this all into your calculator at once, or you can do this step by step. So if we want to do step by step, we can put all of our information for our numerator into our calculators. So we can go 2 times pi times 1.50 times 10 to the 11. And in our calculators, we'll get a pretty big number. It actually will probably likely give it to you in scientific notation. So here we should get about 9.424778 times 10 to the 11. And then we'll divide it by our denominator there, which is the 31,557,600. So go ahead and divide those two numbers, and we should get 29,865.319 as our value. And just to figure out where we're going to round our answer, we do need to consider our significant digits. And so for significant digits, here we're just multiplying and dividing, so we just have to look at what kind of values we're given. So in terms of our radius, here we have 3 significant digits. And then in terms of our period, we have to actually go back to our original conversion, which this one here had 5 significant digits, making our period 1, 2, 3, 4, 5. So the 7 is the last significant digit. So here we have 3 significant digits in our numerator, 5 in the denominator. When we're using our multiplying and dividing rules, we go with the least number of sig figs. So we need to go to a total of 3 significant digits. So our 8 there becomes significant, but we also do have to consider rounding. So the 6 is going to round the 8 up to a 9. So here we get 29,900. Or we could put this into scientific notation where we have 2.99 times 10 to the 4, and then our units here are in meters per second. So now that we've done all our calculations, this one here did give us a little bit of a situation, so we should write a sentence with that. So we can say that the speed of the Earth is 2.99 times 10 to the 4 meters per second. And once you guys have written your sentence, then you guys have fully completed your question. So that is everything here for this video. So if you guys have any questions, make sure to come see me in class, or you can text me on Remind 101. And thank you so much for watching.